Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to help with troubleshooting the installation of electric strikes. This video will discuss and talk about several different topics that will be listed below this video with a minute marker, so that if you want to look at or hear a specific topic, you can jump right to that part of the video. So the video starts with the electric strike not making a buzzing sound after you've installed it. And while I suppose there's lots of things that could potentially be wrong, and first and foremost, the strike may just be broken, defective, and need to be returned or replaced. Where the discussion of a strike not buzzing starts is, first, is the strike getting power? Do you have power going to the strike? So to test for that, generally you would remove the strike and disconnect the wires. And you'll want to be very careful with the wires, because it's possible that you don't know what voltage is there yet. You could have line voltage, so you want to be exceptionally careful with that. And probably engage an electrician or someone who makes a living that has training in electricity, so that you don't harm yourself or the building or the hardware. So first question is the strike getting power? You'll want to have a voltmeter and check for that. You could have an instance where you are not getting power. Then you know that the problem is upstream from there. You could have an instance where you have power coming to the strike, but with the use of the voltmeter, you'll be able to determine what power it is, what voltage it is, and what type of current. Is it alternating AC current or direct DC current? Once you know for sure the power that you've got at the opening, you then need to make sure that your strike is compatible with what you're supplying to the opening. At that point, you might have an AC strike, but you've got 12 volt DC coming to the opening, or any sort of combination of mismatch like that. You could be supplying AC voltage to a DC strike, and that would be the problem there, because inherently AC strikes do make a buzzing sound. Or maybe you have a DC strike with AC power. Or you could have DC at both ends and it simply doesn't make a buzzing sound, which is standard because DC strikes do not buzz. Their operation is silent. They're specifically intended sometimes, when selected, for the silent operation. If you have, you could have a nursing home application and you don't want to hear the buzzing sound all day long. That would be a very improper use of AC strikes. You would opt for a DC sort of installation. If you don't have the right power coming to the opening, you're going to want to go further up towards this power source. The first thing you'll probably encounter will be a transformer. Is the transformer properly rated to be mated to the strike that you're connecting it with? You'll want to check with that. If you've got a DC strike and AC power coming in, you might need a rectifier. So the bottom line is this: checking the power coming in is going to be the first and most important sort of condition to investigate. Do you have the proper power coming in as required by the electric strike? If you have any questions on this section, please feel free to reach out to us. Okay, so at this point now we're moving on to the strike is getting power but does not release. Very common. I've been involved in field troubleshooting this sort of situation many times. It boils down to the first part of this video, strike not buzzing. So the first thing to do is that you know that you're getting power but the strike doesn't release. You need to now check to make sure that the strike is receiving the proper amount of amperage, and that the proper amount of voltage is being delivered as well. Too low an amperage will not deliver the amount of voltage at a force to operate the strike. Typically, a strike without the without the proper amperage at the rated voltage will often cause a weak or erratic sound on AC power. I've also noticed when I've been called to job sites where I go to the opening and the strike's not working, and the strike is known to be good because it's been tested, I say, well, where's the power coming from? And then somebody points, and it's a 50,000 square foot building, and the wire run of low voltage is 500 feet. So that tongue-in-cheek sort of story, and that's a true story, by the way, and you know who you are, customer, maybe drive 50 miles on a Saturday. You've got to get that voltmeter and make sure amperage and voltage is correct for what the strike needs to have. Very important. Okay. Another thing, doesn't happen often but has happened, is the strike a fail-safe unit, meaning that the strike is locked or energized when power is applied to the opening. Or is the strike fail-secure, meaning that when the power is cut, that the lock is in the locked position when there is no power. So let's talk about that again. You've got fail-safe and fail-secure. Fail-safe electric strikes are unlocked when there is no power. Fail-secure electric strikes are locked when there is power. FSE is the common abbreviation for fail-secure. Fail-secure strikes are required in those instances where, in the event of a power outage, the doors are still locked. Think of a mental institution. That is a very real and appropriate, nursing home as well. That is a real and appropriate application for fail-secure strikes. If it's residential and the door is not fire-rated, fail-safe is a good idea so that the fire department doesn't have to break the front door open in the event that there's a fire. The point of all that is, are you sure that the power is applied or is cut in sequence or synchronization with the type of strike you have? If you've got a fail-secure and the strike does not release, are you cutting the power? Which would make sense because in the event of no power, a fail-secure is not releasing. So you might have a synchron, or it could be the normally open or normally closed sort of switch that you're using. You'll need to investigate that as well. Also recommended is that you check the transformer. If you have an existing transformer, check to make sure, and this goes back up to the first part, check to make sure that the transformer is doing its job correctly as well. A much more common scenario, strike is getting power but does not release. Make sure that there is no binding of the latch of the lock within the cavity of the strike. So taking just what I've said there, make sure that there is no binding of the latch of the lock within the cavity of the strike. So what I mean by that is this. You can very likely have a scenario where you have an electric strike and the depth of what I've called the cavity or the keeper is not sufficient for all of the latch bolt to fit inside of it. That means that the latch bolt is not fully projected. It's still being hung up inside of the lock, and as a result you've got too much stuffed in there to get the keeper to release. The example of that is if you are using an electric strike that is intended for a latch projection of 1/2 inch, which is by far the most common of electric strikes, and you're using it with a latch that has a 3/4 inch projection like a mortise lock, that for sure is going to cause a binding issue 95% of the time. And if it doesn't work, it's only by accident that it doesn't work. That's a very common situation. So when you're ordering an electric strike, you need to be sure that the depth of the keeper is compatible with the latch bolt that's being used. But not only compatible with the latch, you want to make sure that you've got the right type of latch. For instance, you couldn't use a regular electric strike keeper shape with an exit device. You have to have what's called a Pullman keeper for that. So compatibility between keeper in the strike and the latch that it's locking is critical. And if you don't have compatibility there, you could and would expect binding from the latch of the lock and the cavity of the strike. Additionally, though, you could have a simple mechanical or installation issue. You could have weather stripping that is preventing the door from closing and getting latched in the strike. You could have a bowed door, a bent door, a broken door, misaligned lock sets, anything not where it ought to be. You could have a door that's now sagging like this, and now the latch is dropped below where the keeper of the electric strike is. You could have a frame that's damaged or twisted, hinges that are no longer sufficient to do the job. All of that will contribute to the door not to the latch and the strike not working correctly together. The old saying is, you know, if you're a 1/16 of an inch here and a 1/16, you know, you got all these little 1/16 of an inch issues. Before you know it, you get to 1/2 of an inch. So you could have a variety of small little issues that all, you know, add together to give you a situation where the lock is not properly latching. Also, you could have a condition of what's called preload, where when you push the door closed, it kind of wants to pop back out at you a little bit. Or you could have a door closer installed where, or you could have a situation where the door is pushing against the face of the frame too much, with a closer or maybe with spring hinges. It's pushing in too far. A lot of strike models are very intolerant of any sort of load, preload that's on the mechanical closing hardware, because the strike is not meant to have any sort of pressure on it, pushing it in or out. That could cause a problem. Finally, is there an electrical problem with this item that you're using to either supply or cut power to the strike? The physical button itself, whatever it might be. Doorbell button, intercom, is there a physical problem with what you're using to actually activate the opening? Those are all things that you'll want to review carefully, and if you have any questions about this aspect, please feel free to reach out to us. Thank you. Now, continuing on with our discussion of troubleshooting electric strikes, the next subject is how to stop a strike from making a buzz or buzzing sound. Typically, in this instance, while it's somewhat uncommon, maybe down the road it's determined that the buzzing sound is no longer something that can be allowed or permitted, whatever the case might be. The buzzing sound is inherently an AC sort of installation. You've got an AC strike. What you can do in this sort of instance is buy a DC version of the electric strike, and it's possible that if you've got a strike that you can replace only the solenoid, you might be able to replace it with a DC strike. You would then add in line a rectifier, something that is going to transform AC voltages to DC, allowing the use of a DC strike. Whether you've got a plug-in or a hardwired AC transformer, you can add that rectifier after the transformer to flip the voltage to DC, and that will successfully convert AC voltage to DC. It's very common to use because regular electric is, you know, line voltage will be coming in at AC, and it's very common to have DC strikes, which will not make the buzzing sound. Now keep in mind, an AC strike is going to burn out if you apply DC voltage to it, as the coil resistance in the strike cannot handle the constant current of what DC power would provide. So to stop a strike from buzzing, you're going to replace it with a DC strike and add a rectifier. If you have any questions on how to go about doing that, please feel free to reach out to us. Thank you. The next section to discuss in troubleshooting strikes is how to make a silent DC strike buzz. Well, that's done pretty much generally exclusively when you are dealing with a DC strike that it's set up for intermittent duty, and that is fail secure, meaning a power to unlock situation, where the buzzing sound is what announces the door has been released. So to add a buzzing sound to a DC installation, you would add a piezo DC voltage buzzer matching the voltage of the electric strike. While that is something that we don't sell, you would reach out to an electronics company for providing that. So the DC buzzer is added to the circuit across the wire leads of the strike in parallel. That allows for tucking the buzzer into the frame with or behind the electric strike. You'll want it close, obviously, and somewhere in the frame would be the idea, right behind the strike. So that's the instance where you would go about doing that. You might have a DC installation and simply need to know, someone needs to be able to hear when to pull in, because a DC strike, quite frankly, is just a clicking sound is all you really hear. And it's really just the solenoid releasing, and you don't hear it all the time either. So that you might have a need for a much louder buzzing sound. And if you do, that's how you go about doing it. Any questions how to accomplish that or any other aspect of this section, please feel free to reach out to us. Thank you very much. Time for some definitions. First one is intermittent duty. What is intermittent duty? What does it mean? In regards to electric strikes, that generally means that the magnetic coil design is not intended to be energized for periods longer than about 1 minute intervals. The AC coil resistance, which is measured in ohms, is not high enough to withstand the heat generated by a constant electric current. The heat buildup can short out the coil windings, leading to failure as well, provided the coil has not shorted out. The life cycle of the strike will be reduced if you're using it in a continuous sort of duty, because damage to the coil is inevitable. Usually, AC strikes are fail-secure sorts of actions or operations, meaning that the power is provided only momentarily to unlock the strike. That would be a very typical application and definition of intermittent duty. Thank you. Continuing with definitions, what is continuous duty? The type of electric strike coil that is rated as continuous duty, the coil has typically a higher resistance, again as measured in ohms, as compared to AC coils. They are designed to handle the constant electrical direct current of DC voltages. This allows for DC strikes to operate in a prolonged period of time where in an energized state. In this case, a DC strike model is available in both fail-secure and fail-safe functions. The fail-safe function requires constant power to be locked. Okay, so fail-safe requires constant power to be locked. When the power is cut, the strike is unlocked. Fail-secure DC models can be used to allow for a strike to be kept in the open or unlocked position for extended periods of time by keeping the strike energized. That is a typical installation for both of those duties. If you have any questions on continuous duty, please feel free to reach out to us. Thank you. And another definition, this time preload. Preload is a term used to describe a condition upon the electric strike, or the keeper specifically, when it has outward pressure on it, meaning that there is pressure of the latch making contact with the inside face of the keeper in an opening direction. Generally, it is due to a misaligned strike and lock set, allowing the latch bolt to apply that outward pressure to the inside of the keeper from the face of the latch bolt. In a lot of instances, if a strike isn't working correctly and you do have preload, in a lot of instances the amount of preload can be so great that in a lot of strike models, the coil would not have the ability to mechanically release the keeper because the preload pressure binds from the keeper to the face of the latch. If you've got this condition, check for proper alignment between the latch and the strike, with the door both open and closed. That's how you'll test for preload. When the door is open, then use the strike and make sure that it operates correctly, because in that, when you're testing, you won't have any preload applied to the face of the keeper. Additionally, again, the hinges on the frame should not allow the door to sag at all. The door closure should hold the door to the frame stop and not partially open, because that's where the preload comes in. The electric strike cavity depth and width should be of the proper size to accommodate the latch bolt. We talked about that earlier in this video, where you've got to make sure that you have a compatibility between the latch bolt and the depth, height, and width of the keeper as well. And you need to have a bit of tolerance around the inside of the cavity for the latch bolt to move. Not enough to cause a problem, but just enough to be comfortably placed and fitted into the keeper. If you've got weather stripping installed on the frame stop, that could provide preload as well, because the door is going to be pressed against the weather stripping of the stop, and that weather stripping needs to make constant contact with the door to be effective. Well, sometimes you've got to push the door closed, which means it wants to come back out, and that condition will give you preload. So you want to make sure that you've got weather stripping just touching the door, but not preventing an electric strike via preload to do its job. If you've got any of these conditions, generally they can be remedied. You're going to want to check the weather stripping to make sure that it's not, preloaded. Maybe move it back a little bit. Check for a bowed door condition or frame where you might need it to be replaced. An electric strike that buzzes erratically or opens only intermittently is also a telltale sign of a preload condition. If the strike keeper can be opened with only finger pressure while holding the door open, again, that strike is completely functional. So you want to check your installation aspect if you have a preload condition. First, test it with the door open, test it just with your finger to make sure that the strike is functional. If it is, then you have to move on to the hardware. Well, probably compatibility. Do you have the right stuff working together? Then move on to the mechanical installation aspect of the installation. Any questions on preload, please feel free to reach out to us. Thank you. Checking for the electrical condition of a strike means checking the health of the strike electrically. And that is done by testing the ohms or reading the ohms that you're dealing with on the strike. Ohms is voltage divided by amperage. We'll say that again at the end. If the health of the coil in the electric strike is not up to the task, you will experience a strike that is misbehaving. So testing the ohm reading of the coil can tell you whether the coil windings are in good condition or not. It's the windings that are what creates the magnetic field. When you've got electricity applied to a coil, it creates a magnetic field. And that magnetic field is what makes the solenoid move, which will either lock or unlock your strike. Meaning that it manipulates the mechanical mechanism in the strike itself, the steel part inside the solenoid, to be either open or closed. If the windings have been damaged, the strike may not lock or unlock. If they've been corroded, if they've gotten some sort of treatment that is outside of what they're engineered for, you'll have a problem with the strike. So rather than replace the strike, that handy voltmeter will allow you to determine what you've got at the strike compared to what the rating is of the strike, assuming that you can determine what that is, maybe by a sticker from the back side of the strike. When the resistance or the ohms go up, the amperage goes down, and the coil may not have enough power to develop the proper magnetic field. That's where the problem comes in. If resistance goes down from the coil, it will draw more amperage than the power supply is rated to deliver, and that could damage your transformer. So if the resistance goes down from the coil, there's going to be more amps coming in, or it could request more amps coming in from your transformer than what the transformer is rated at. And so you could have problems above stream or upstream from the strike. By reading the ohms with a meter, you can compare the rating of the electric strike compared to what you got. The voltmeter, or the reading with your tool, comparing what the strike is putting out ohms wise and what it's rated for. Usually the voltage, amperage, and ohm rating can be found on the product label or the manufacturer's catalog. So you want to do some investigative research if possible, so that you can, before you replace a strike, determine what it is, because your strike might be fine, and it might be the much less expensive transformer that is the problem. Again, voltage divided by amperage will give you the ohms. Any questions on checking the electrical condition of the strike, please feel free to reach out to us. Thank you. Now we're going to discuss checking the transformer. The transformer is almost always a necessary item. It's unusual to have, not unusual, but it's in electric strikes it might be less common to have line voltage coming all the way to the strike, even though they are made for that as well. But if it's low voltage, 8, 12, 16, 24, there's a transformer somewhere in play. Transformers are used to step down the higher line voltage, 120 volt or whatever it is, down to a lower voltage to operate low voltage devices such as electric strikes. There's basically two types of transformers. There's the plug-in style, and then there's the hardwire. Now the plug-in style is exactly what it sounds like. It's going to be a transformer that you will have that you've seen in a variety of installations. You could have a doorbell with a plug-in transformer, I suppose, where it literally has a plug to go in a typical 120 volt outlet, and then it'll have 2 terminals on the back, you know, or whatever the configuration of it will be. But rather than hardwiring it, where you've got line voltage wires coming to your transformer and then terminals coming off, you can just set your low voltage device wire to it and then plug it in. And a lot of installations require that because you can't run, or maybe it's just more convenient to have a low voltage, a plug-in style transformer. Now the hardwire type is often mounted to an electrical box through a 1/2 inch knockout. And again, the plug-in version is just connected to a wall receptacle, a typical wall outlet. The hardwire most often are AC current outputs. The plug-in type are available in AC or DC current output. The AC hardwire type can be converted to AC by use of a rectifier, making sure that you have an amperage rating sufficient for what you're delivering. The transformer should be matched appropriately to the device load. What we're meaning there is that the voltage, the current, and amperage all have to be accounted for to operate the load correctly or properly. Often transformers may not show the amperage rating as amps, but give a VA rating. The voltage times the amperage equals the VA rating. So voltage times amperage is VA. So that's how you'll be able to determine that. To figure the amperage when giving a VA rating, divide the VA by the voltage. So to figure amperage, if you know the VA rating, divide VA by voltage, and that will give you amperage. Use a meter to read the voltage at the transformer and then at the electric strike. Do this by placing the 2 meter probes first on the transformer connector, then at the 2 strike connections. Now DC transformers have a positive terminal and should be checked with positive polarity. Compare the voltage reading of the wire leads in the frame to the transformer. This will confirm that the strike is receiving the proper voltage and that the transformer rated output is sufficient to operate the strike, both at the transformer and after passing through the wire run to the strike. If the voltage at the strike is significantly different than the transformer output, check the wiring, either for integrity or for length of run. If you have any questions on checking the transformer, please feel free to reach out to us. Thank you. A very important aspect of electric strikes and electrified hardware in general are wire runs, meaning the physical wiring between power supply and the item doing the work. Wire runs in general should be kept to a minimum distance from the power supply, and wire runs of less than 100 feet are really the best. Doing so avoids adding resistance to the power output of the power supply to the electric strike. And if it's no matter what, you create a voltage drop through your wire run, but keeping it to the minimum amount allows the strike to get the proper amount of electrical characteristics that it needs. Wire resistance, measured in ohms, can be changed in 3 ways: length of the wire, diameter of the wire, and by heat. The longer the wire, the longer the voltage has to travel. If the wire diameter is thin, then the voltage has to squeeze through a very small wire. If the wire is exposed to excessive heat, then the wire builds resistance through that heat. So it's a combination of all of those aspects. As resistance goes up, your heat will go up, which will hamper, getting the proper stuff, value to the strike itself. Look to create power supplies not far from the strike location. Wire size should be a minimum of 20 gauge for short runs. Avoid hot attics, black tar roofs, running wires close to hot water and steam pipes. It's not a good idea. Stranded, insulated, twisted pair wire are recommended. Solid core jacketed phone wire should be avoided, especially when snaking wire over ceilings, behind walls, into door frames. Stiff wire is prone to breakage, and the insulation is easily damaged. You can be pulling wire through something and catching it on any sort of sharp material. That would be a problem. Twisting wire and screw connectors tend to crack and break solid wire and small gauges. So you'll want to make sure that the wire that you're using for the job is sufficient to provide assurance against mechanical wire breakdown. Thank you. Continuing with our discussion brings us to checking voltages, which is very much alike to the checking transformers earlier in this video. All devices in an electric strike current should be rated at equal voltages. So what this means is that all electrical components should have the same voltage rating. A magnetic coil is designed to perform at a certain power to operate the strike. When the strike coil does not receive the appropriate voltage, a proper magnetic field is not created to operate the strike. As voltage lowers, so does the amperage, further reducing the power. Selecting components of the same voltage rating will help ensure that the coil does not run hot and possibly lead to coil failure or premature deterioration to the operation of the opening. The idea is that you want it to mechanically work correctly for an indefinite period of time. You want the significant investment in hardware to work. And where that all starts is by, again, selecting material of the same electrical characteristics. Of equal importance is a strike that places a burden on an underrated transformer, causing it to fail. You got to make sure that all of the components, the wire, the strike, the physical installation, the power supply or transformer, are all on the same page. Transformers have their voltage rating affixed by a label or can be checked with a voltage meter. Now, determining the voltage of electric strikes can be accomplished in a few possible ways. First of all, the label that's on the box or on the strike itself will very often reveal very useful information. While sometimes it's not specifically clear what it is that you're dealing with, what always is clear is the use of the voltmeter that we've talked about. Some manufacturers use color-coded wire leads or print specs on coil tape. The ohms of the coil should be checked and referenced to a manufacturer's catalog or data sheet. Absolutely reach out to us if you know the strike. We can get some photographs from you. We can contact the manufacturer and find out what the voltage characteristics are of what you're working with. Knowing the resistance, again in ohms, of the coil will reflect a specific voltage and confirm whether the coil is in good condition as well. If you have any questions on the checking of the voltages at this point, please feel free to reach out to us. Thank you very much. Here are some possible causes when a strike is having its coil burnt out prematurely or at all. AC coils, AC strikes, AC rated strikes, their coil will burn out, will burn out, if that strike is operated at the same voltage in a DC current. The lower resistance of the coil is unable to handle the constant direct current. The power builds up as heat and may short out or fuse the coil windings. So, electricity through a coil creates a magnetic field, makes the solenoid do its job. An AC coil, if it's operated at the same voltage as DC, will damage, impede, fuse the coil windings of the mechanism itself so that it will not operate properly. Being that AC strike coils are intended primarily for intermittent duty cycles, no longer than 1 minute, a stuck button, the button by which you are depressing to energize or de-energize the strike, if that's stuck, or a shorted wire run could cause the coil to fail as a result of that condition. Holding a door open for an extended period of time, meaning you've got the strike and you're firing it for too long, meaning energizing the strike for prolonged periods of time, will work to reduce the life of the AC coil. AC coils require more amperage and as a result generate more heat to the windings. Transformers with overly rated voltages can also cause an AC coil to burn, but that's also true for DC coils. Some strike models that are burdened with a door preload may cause the AC coil to overheat, as well as someone continuing to hold the button as an individual attempts to take the load off the door for the strike to open when entering. So what that means is if you know you've got trouble with a door and you're up in the apartment and you're trying to buzz the pizza man in, if you're constantly hitting that or leaving it for prolonged periods of time while the person's trying to get the door open, will also contribute to that sort of problem. Proper door hanging is the cure for that. Any questions on this aspect? Strike coil burning out? Let us know. This section of the video is called Matching the Grade. Now, lock hardware is graded by standards that are developed through the BHMA, Builders Hardware Manufacturers Association. These standards, when independently tested, are granted a grade level recognition. Electric strikes are also graded and non-graded. Not only are graded and non-graded, not only lock sets carry a certain grade level. So you've got material that is rated in terms of a grade standard that is other than lock sets, meaning not only lock sets are graded, electric strikes are too, and other electrified hardware. When selecting an electric strike, many of the hardware configurations and features are taken into account by the design to be compatible with the lock sets of a similar grade level. Meaning, when you order the lock, look at the grade level and make sure that the strike is on the same grade level as the lock. Strikes that have no grade level will often accommodate similar locks, meaning those locks without a grade. That's a delicate way of saying if you have a grade 1 lock or a grade 2 lock, avoid an electric strike that is not graded at all. If you have a lock with no grade, maybe don't order the heaviest grade electric strike. Make them equal in that regard. What happens often is that an inappropriate non-graded electric strike is selected to accommodate a grade 1 heavy-duty lock set. So just speaking in general, grade 1 is always considered heavy-duty, maximum rating. Grade 2 would be considered standard-duty commercial, and grade 3 would be considered residential sort of application. So keep that in mind. Typically, you will find a grade 1 lock set in a high-traffic, heavy-duty application. And a lock that is built to stand that sort of use, high-volume use, it can easily or quickly overwhelm a low grade, meaning a higher number, or a non-graded electric strike. What happens is that in short time, the lock set will damage a strike beyond it being operative at that point. A heavy-duty mortise lock with a steel 3-piece anti-friction latch and an auxiliary dead latch feature matched with a light-duty electric strike with a narrow-style cast faceplate, maybe a zinc cast keeper or a shallow cavity depth or height designed for wood frame applications, leads to malfunction is the bottom line. So when you're talking about making sure that everything works compatibly together, if you're going to invest the amount of money to have a top-end lock, you've got to match the strike with that. Word to the wise. Don't have don't have this sort of condition with strikes and latches. Thank you very much. The next section of this video is to talk about auxiliary ramps, and it's a reference to electric strike design, not to any sort of handicap compliance wheelchair ramp construction. So mortise locks that have an auxiliary latch feature that make the latch bolt a dead latch require electric strikes with an auxiliary ramp configuration. Here's what that means. You've got the latch bolt and it sticks out of the edge. That latch bolt is intended to go into the hole of the strike. In those instances when you have a mortise lock that have an auxiliary dead latch, meaning that when that dead latch is depressed and held in, the latch itself cannot be pushed in. That is a standard configuration for many mortise locks, meaning that when the door is closed, the latch can go into the hole in the strike, but the auxiliary deadlocking latch is kept pushed into the lock, and it's that action that prevents the latch from being pushed in because of the inner workings of the mortise lock. So if you've got that sort of mortise lock, you have to take into account that feature when considering electric strikes. Now, narrow style strikes will not accommodate auxiliary latch features. The auxiliary ramp is required for allowing the auxiliary latch to ride up the face of the frame and be depressed into the lock set, making the latch a dead latch. It's very important. You don't want people tampering with the latch bolt and being able to easily get in through that doorway. Also, the ramp section needs to fill in the cut in the hollow metal frames, and certainly not exposing any sort of hole that has been prepared to allow the latch bolt so that it has a clear path to the strike's latch keeper. What we're trying to say there is make sure that you've got compatibility between the model of electric strike and your mortise lock with an auxiliary dead latch. If the auxiliary latch of the latch bolt did not have that proper path to follow, preventing it from hitting the frame edge first, the door may not completely close, because if the dead latch is being hit prematurely or when it's not supposed to be, your latch bolt will not be able to depress, because that's the proper sort of function for that material. So preventing it from hitting the frame edge first, the door may not close properly due to the latch hanging up on the edge of the frame, the auxiliary latch. In the case of the auxiliary latch, it will often break off or hold the door open, and the latch bolt can get stuck between the strike keeper and the hole in the edge of the frame, possibly jamming it. Narrow style electric strikes are suitable for wood frame applications where the thickness of the frame prevents breaking through into the hollow part of the frame. Typically, the frames are 3/4 inch thick. Narrow style, non-grade electric strikes commonly have a cavity depth of only 1/2 inch, and that would not be an appropriate depth of the keeper to accommodate a mortise lock, which are almost in all instances, every instance I can think of would be 3/4 inch. If the strike that you're using is acceptable for a non-graded lock set, cylindrical or mortise, you'll need to make sure that your projection is 1/2 inch. Therefore, the installation requires the 1/2 inch of wood be removed from the rabbet area of the frame where the pocket of the door where it's going to sit into, and be sure that you have a latch path for the auxiliary latch. This allows the strike keeper to pivot open properly when the door is opened, when the strike is energized or de-energized, whatever the condition might be, and then to properly work. Any questions on auxiliary ramps? Please feel free to reach out to us. Thank you. If you have a condition where the door does not latch completely shut, you could have a problem with the faceplate of the electric strike not being fully mortised or flush with the frame. A lock set latch bolt that is not completely compatible or having the proper taper or bevel that does not engage properly with the strike keeper's face is also another cause of a door not latching properly. That taper of the latch is the area of the latch bolt that comes in contact with the face of the strike, or what's called the keeper, causing the latch bolt to depress momentarily into the lock set and then springs back out into the strike keeper or strike cavity. When the latch bolt meets the strike keeper, the proper angles on both the face of the latch bolt and the face of the keeper allow the latch bolt to ride properly into the strike cavity or strike keeper. You'll want to make sure that the two pieces of hardware are indeed compatible with each other, and if you find that you're not, you'll need to replace one or the other. Thank you. If you have a condition where the door closes but the strike keeper does not lock or keep the door in a locked position, there are some electric strikes available that are what is called hand changeable or reversible. You could have whatever hand the door is. You could have the strike installed in for the opposite sort of hand, and that if it is field reversible, you can generally take the mechanical part and flip it over or adjust it to operate in the reversed sort of condition. Some types of those strikes, if fail secure, locked without power, may be in the opened position if installed upside down or in the reverse hand of frame. Meaning, if you had a right hand installation but the opening was actually right hand reverse, you would have a reversed situation where you might need to reham the strike. Always keep in mind that fail safe action means that it's locked when it's energized. So fail safe equals power to the circuit locking the strike. And then fail secure is the obvious. When power is cut, it's locked. Meaning you could have the door unintentionally unlocked and just not realize that the circuit is in the opposite condition of when you need. Also, I have found the same sort of problem with a long wire run where there was not sufficient, it's just not working correctly because there's a significant voltage drop getting it to the opening. There are the world of electric strikes. There are an almost uncountable amount of options and accessories. And what's nice about electric strike manufacturers is that they have really accommodated every need for electric strikes. And electric strikes are a very important part of hardware as it relates to society. Whether it's an intercom on the front door of an apartment, or if it is all the way up to a laboratory run by the federal government that needs to have card access. Electric strikes are everywhere. They're prevalent. Every single grade is available depending on the installation requirements. So be sure that when you're considering an electric strike that you made it up properly to the other components that you're using it with, electrically and mechanically, but also make sure that you are getting a strike that will work within the designed requirements of the installation. Again, something like a nursing home, power goes out, storms, flooding, whatever the case might be. You definitely do not want a stairway or an access to the outside of the building giving you a situation whereby someone has been able to exit because of that condition. While it might seem common sense, it does need to be stated that electric strikes have to be ordered depending on what the designed end result is of the usage of the building. A variety of manufacturers we distribute for, and there are several great ones that I like, some less than others. However, the ones less than others generally are for a different application. So knowing what your installation requirements are, knowing what you're going to expect of this electrified hardware is really the first step in making sure that you get the correct material. My name is Rich Howard, owner of Architectural Builder Supply. By all means, if you have any questions on how to specify, how to install, prep a door and frame for, or troubleshoot down the road, please feel free to reach out to me. Thank you very much.